The standard model of physics predicts that the Big Bang generated a perfectly balanced ledger. For every single particle of normal matter forged in that initial flash of creation, an exact equivalent of antimatter was also born. Matter and antimatter cannot coexist. The moment these two opposing particles shatter against one another, they annihilate. The mass of both particles is destroyed, instantly converting into a violent, expanding wave of pure energy. Because the universe started with a strict 1-to-1 ratio of these opposing particles, they should have all annihilated moments after the Big Bang. That early universe should have burned itself out in a flash, leaving behind a vast, dark expanse filled with nothing but cold radiation, with no stars, with no planets, and no us. Yet we are here. To explain this presence, physicists point to baryon asymmetry, a slight mathematical imbalance that occurred in the earliest fractions of a second of the universe. For every billion antimatter particles, there were 1,000,000,001 normal matter particles. The billions annihilated each other, but those single leftover particles survived. Everything you can see, touch, and experience, including you, is built from those rare surviving anomalies. The hunt for antimatter is an attempt to track down the missing half of our origin. Identifying antimatter on a subatomic level requires looking into a mirror. It is identical to normal matter in mass and spin, but carries the opposite electrical charge. A normal hydrogen atom has a positive proton and a negative electron. Its twin, antihydrogen, has a negative antiproton and a positive positron. This mirrored realm was mathematically proven to exist long before anyone ever observed it in the laboratory. In 1928, physicist Paul Dirac wrote down an equation to describe the behavior of electrons. The math produced two solutions, one for a particle with a negative charge and a second for a particle with a positive charge. He had predicted the anti-electron. When these opposites meet, the resulting reaction follows Einstein's mass-energy equivalence with absolute efficiency. Nuclear fission converts only about 1% of its mass into energy. Matter-antimatter annihilation converts 100% of its mass into raw energy. Despite this energy potential, you won't find pools of it sitting around on Earth. Primordial antimatter, the raw material forged in the Big Bang, is practically non-existent in our natural environment today. Because any newly created antimatter instantly vaporizes itself against the normal matter of our atmosphere, scientists face an extreme physical problem. They have to engineer a container for a substance that cannot touch physical matter. That problem is currently being addressed deep underground in Switzerland. The antiproton decelerator at CERN, the antimatter factory, is a complex of machines designed to manufacture and then drastically slow down these elusive, hyper-fast particles. You cannot catch them in a glass beaker or a steel vault. The moment an antiproton touches the atomic wall of any physical container, it annihilates. Instead, engineers rely on a device called a penning trap. This takes advantage of the fact that antiprotons carry an electrical charge. By projecting a cage of invisible magnetic and electric fields inside a perfect vacuum, the trap catches the charged particles and suspends them in tight, spiraling orbits, safely away from the physical walls. But researchers want to study complete atoms, not just isolated particles. To make antihydrogen, they bind a negative antiproton with a positive positron. When these opposites combine, their charges cancel out. The resulting antiatom is electrically neutral. Suddenly, the electric fields holding it in place stop working, and the antimatter drifts right through the invisible cage. To stop this, the alpha experiment at CERN utilizes a minimum magnetic field trap. Even though the antiatom is neutral, it still has a weak magnetic moment. By shaping precise, overlapping magnetic fields and cooling the environment to near absolute zero, researchers can lock the neutral antiatoms in place. Using this method, physicists have managed to bottle the most volatile substance in the cosmos, keeping it stable for over 15 minutes. They have forced the universe's mirror image to sit perfectly still long enough to be examined. This capability is already functioning every day in local hospitals. Positron emission tomography, or PET scanners, work by detecting the microscopic annihilations of positrons emitted from a radioactive tracer inside a patient's body. Researchers are pushing this medical application further. CERN's ACE experiment has been testing a way to direct a beam of antiprotons straight into cancer cells. The goal is to trigger an annihilation event exactly at the depth of a tumor, blowing the target cells apart while leaving the healthy tissues along the beam's path unharmed. In the lab, experiments like AEGIS and GBAR are taking those trapped anti-hydrogen atoms and subjecting them to a simple test, dropping them to see how they react to gravity. Because antimatter is a perfect mirrored twin of normal matter, theorists have debated a bizarre possibility. What if it experiences gravity in reverse? Instead of dropping toward the center of the Earth, a cluster of anti-atoms might actually be repelled by our planet, causing it to fall upward into the void. This volatile particle is the direct stress test for the Standard Model itself. If the gravitational response is anything other than a vertical drop, the fundamental equations governing our reality must change. While labs on Earth synthesize fractions of a gram, astronomers are looking upward, searching the deep cosmos for primordial antimatter that survived the birth of the universe. To do this, they mounted the Alpha Magnetic Spectrometer to the outside of the International Space Station. Orbiting high above the interference of Earth's atmosphere, this detector acts as a net, waiting to capture high-energy anti-nuclei passing through our solar system. Instruments like the AMS-02 and the high-altitude GAPS balloon floating over Antarctica are specifically hunting for complex structures like antihelium. Finding a heavy anti-element drifting through space would strongly suggest that large pockets of antimatter exist out there in the dark, perhaps forming entire anti-galaxies. Every antiproton trapped in a lab and every anomaly detected in orbit brings us closer to identifying the mechanism that allowed our matter-filled reality to survive its own birth. We are finally gathering the data to determine whether our existence is a mathematical accident or one half of a mirrored reality.